Okay, today we have our lesson 6.3. A linear function is a function whose graph is non-vertical line. A linear function can be written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. So we also know this as slope-intercept form. So we had learned that earlier as that, but that is also considered a linear function. We talked about this a little bit in an earlier lesson as well. Writing a linear function using a graph. Use the graph to write a linear function that relates y to x. So the points lie on the line, and you find the slope by using the points 2, 0, and 4, 3. So remember, you can choose any of the points that fall on the line. It doesn't matter. And so you find the change in y over the change in x. So if we use those 2 points, we can do, here's our y, so 3 minus 0 over the change in x, 4 minus 2. 3 minus 0 is 3, 4 minus 2 is 2. So we get 3 over 2, so that is the slope, because the line crosses the y-axis at 0, negative 3. The y-intercept is negative 3. So the linear function is y equals, okay, my slope is 3 halves x, oh, sorry, not plus, minus 3. So that should be a minus, not a, let me make that a little darker, minus 3, not a plus, okay? And so just like we learned earlier, that's how we would do that. Using a table, we learned this also as well. We can use a table, and remember, these all create ordered pairs. So this is negative 3, 9, negative 2, 7, negative 1, 5, and 0, 3. That makes all those ordered pairs. So I can pick any of those ordered pairs that I want, and I can find the slope. So let's say we use negative 2, 7, and negative 3, 9. We would subtract 9 minus 7 over negative 3 minus negative 2. And that gives us 2 over, this would be a plus, so that would be negative 1, which gives me negative 2. Because the line crosses the y-axis at 0, 3, which we can see right here, the y-intercept is 3. So the function is y equals the slope times x plus 3. Okay, so we've done this before. This shouldn't be anything new. Go ahead and pause and do your on your own 1 and 2. You can just write your answers right underneath here. Okay, this is what you should have had as your answers. And we're going to move on. So real life application. Okay, so you're controlling an unmanned aerial vehicle, UAV, for a surveillance. The table shows the height, y, in thousands of feet, of the UAV X minutes after you start its descent from the cruising altitude. Write a linear function that relates y to x, interpret the slope and the y-intercept. Okay, so the first thing we have to do, you can write a linear function that relates the dependent variable y to the independent variable x, because the table shows a constant rate of change. Find the slope by using the points 0, 65, and 10, 60. So we would do 60 minus 65 over 10 minus 0 equals negative 5 over 10, which equals negative 0 and 5/10 if we write that as a decimal. Because the line crosses the y-axis at 0.65, the y-intercept is 65. So linear function then becomes your slope, negative 0 and 5/10 x plus 65. The slope indicates that the height, and it's a negative, so it decreases, and it decreases by, okay, so that's half, so it's going to be decreasing by 500 feet per minute, because, so 500 feet per minute. The y-intercept indicates that the descent begins at a cruising altitude of 65,000 feet. Okay. Make sure you consider the units when interpreting the slope and the y-intercept, and that's what we talked about a lot the last time. Graph the linear function, plot the points in the table, and draw a line through the points, and they did that for you. Because time cannot be negative, in this context, use only the positive values of x. And so they went ahead and graphed that for you. Find the value, or find the height of the UAV when you stop the descent after 1 hour. So because 1 hour equals 60 minutes, and we were measuring our x was in minutes, we want to change 1 hour to 60 minutes and find the value of y when x is 60. So you take your equation, y equals negative 0 and 5/10 times x plus 65. We're going to substitute 60 in for x. And we end up, when we do the math, we get 35. So the descent of the UAV stops at the height of 35. And don't forget, we're measuring in thousands, so 35,000 feet. Okay, so what if you double the rate of the descent? Double the rate of the descent. Repeat parts A, B, and C on the next page, and then we'll check it. Okay, so for 3A, your equation would have been, if we double it, it's going to be y equals negative x plus 65. The slope indicates that the height decreases at 1,000 feet per minute rather than just 500. The y-intercept indicates that the descent begins at 65,000 feet. That did not change. Part B would be to graph this. Now, I ignored the axes that they had and just made a new one just because that gave me more room. Don't forget to label minutes and height in thousands of feet. I counted by basically fives, but I skipped every other one. And then I graphed that. Part C would be 5,000 feet. Okay, and the next part we're going to do is we're going to finish up with comparing linear functions. So the earnings Y in dollars of nighttime employee working X hours, so X equals hours, are represented, and earning Y in dollars, are represented by the linear function Y equals 7 and 5/10 X plus 30. The table shows the earnings of a daytime employee. So you have this table, and I know it's kind of hard to see. Oops. There. Okay, so we have this table, and we can see that each time our X increased by 1, our Y increased by 12.5, or $12.50. So which employee has the higher hourly wage? Our nighttime employee, Y equals 7.5x plus 30. The nighttime employee is, since the slope is 7.5x. That means it's $7.50 per hour. And the daytime employee, if you take 1250 over 1, which we got right here, that gives us this is our hourly rate. And so we would make $12.50 per hour here. So if we compare the two, the daytime employee has a higher hourly wage. Okay, write a linear function that relates the daytime employee's earnings to the number of hours worked. In the same coordinate plane, graph the linear functions that represent the earnings of the two employees, and then interpret the graphs. So here you have your daytime, and here you have your nighttime. I should switch the colors. Okay, and if you graph them on the same one, use a verbal model to write a linear function that represents the earnings of the daytime. So we get the earnings is the hourly wage times hours worked. So we get 12.5 times x equals y. And notice that goes through the 0, 0, so there is no y-intercept. The graph shows that the daytime employee has a higher hourly wage but does not earn more money than the nighttime employee until each person has worked how many? Where do they cross? They put right here, 6 hours. Okay, so now on your own, see if you can answer these questions. You have a manager A earns $15 per hour and receives a $50 bonus. The graph shows the earnings of manager B. Here's your graph. Look at your labels and your title. Which manager has the higher hourly wage? After how many hours does manager B earn more money than manager A? So go ahead and take. Okay, and there's the answers that you should have had for that one. Okay, what I would like you to do next is I would like you to work on the performance tasks. I would like you to skip this one, and it goes all the way on both of these pages, and also skip part D. So we're going to start with a restaurant one. So you're going to do this one. You're going to do A, B, and C. Then you're going to do this one. And then this one. So there's several parts to this. You're going to go ahead and start working on that, and then we'll just. Oops, and I forgot one more. We had one more. This one's number 4, and that goes over onto the other side as well. So you have quite a few of these that you're going to work on in class.